In this video, we're going to be going over domain and range. And when we talk about domain and range, there's some terms that we have to know. One is, what is the independent variable? And when we talk about the independent variable, we're talking about the input variable of a relationship, often represented by the variable x. When we talk about the dependent variable, we're talking about the output variable of a relationship, often represented by the variable y. Now, when we talk about domain, it is the set of all possible independent variables of a relation. In other words, it's all our x values. When we talk about range, it is the set of all possible dependent variables of a relationship, or all our y values. Now, those are four things that we do have to remember as we're going through domain and range. And I want you to keep in mind that I'm using pink for the x and I'm using black for the y, so that we can kind of see as I'm creating my domain and range for my graphs. I want you to see which one is which. So let's see. Here it says, what is the difference between continuous data and discrete data? Well, when we talk about continuous data can take any value within a specific range, while discrete data can only take certain values. And let me give you an example. If I were to write the domain, let's say that this is my x-axis here, and this was my domain. Notice it has a closed dot, and then it goes all the way over. So we can write an inequality about this because it can take any value between this dot and infinity, going positive. So our lowest number is -2. So this would be -2 is less than or equal to, because it's a closed dot, x, which is less than or equal to, and since this goes on forever, on this particular graph that we've seen right here, we would say infinity. So this is an inequality, and infinity just means all real numbers, and this is my domain. Now, we don't have a range here because it doesn't show what y is, but if we had a y value, let's say we did. Let me draw another one of these. Let's say we had a y, and say it started at -1, and then we had 0 and 2 and so on. And let's say that this particular, I'm actually going to draw a circle here in pink. Let's say we had a closed dot on -1, and then it went on forever. And this is my y. So I'll change that to black. So this is my y, up and down. It starts at -1 and it goes on for infinity. Well, your range would be -1 is less than or equal to y, which is less than or equal to infinity. So this is just one example of writing an inequality for continuous data. Now, in discrete data, it's not the same. We don't write inequalities because it's not everything in between, but it's specifically just the points that are listed. And so let me give you an example of what that would look like. If we're writing discrete data, first of all, we're going to use brackets for our domain. That's going to represent my x. And in this case, we have a dot at -2, -1, 0, 1, 2, 3, and 4. And let's say it ends there. So we put our smallest number to the left. So we have -2, -1, 0, 1, 2, 3, and 4. And then we close brackets. And that is my domain right there. Now let's say, hypothetically, because this graph is really small, it's hard to see. Now I'm going to make a number line. Let's say we had a number line representing y. And let's say it started at +1. And then it went to 2, and then 3. And let's say we had 3 points on that number line. Well, if we wanted to write our range, then what we would end up having is we would end up having a bracket, and then we would just have the values 1, 2, and 3, because that's as far as it goes. So just keep in mind, that's kind of a crummy looking bracket, but keep in mind that this would be our x up here, and I should have put this in pink, but I didn't. I put it in black, and this is our range, our y values. So we're literally just be listing the values of y that are on the number line, going vertically, and just like we'd be listing the values of y going on our x-axis, which would be horizontal. So let's try this again down at the bottom and see if we can make more sense of it. Right here it says find the domain and range of the given functions and write an inequality representing its domain and range for continuous data, or write the domain and range set for discrete data, because we're going to write it two different ways. Now notice this is linear right here, and just for grins I'm going to say that this is a open dot. Let's say there's an open dot at this point, and let's say there's a closed dot at this point at origin where that line ends. This way you can see that there's going to be a difference between open dots and closed dots. For instance, whenever you have an open dot, you will use the less than or greater than symbol. Whenever you have a closed dot, you will use the less than or equal to or greater than or equal to symbol. And the reason is when you have a closed dot, it means it actually touches that number. So it can be that number. But when you have an open dot, it means that you get close to that number, but it never actually touches it. So if we were looking at this first problem, if we're talking about domain, we're talking about our x values. Well, my open dot stops here. It starts here, and then it stops here. So that's my domain. So I'm going to write domain inside of there and put an x. So in other words, all the values from this point all the way over to this point are my domain. And we're talking about left and right because it's x values. Well, if I go right here and I count back, that's 1, 2, 3. So my domain lines up with -3. So I would go ahead and in domain I'd put -3. And since I had an open dot, I will say that it is going to be less than x. And then on this side, notice we have a closed dot. So and that's at origin, that's at 0. So then we'll say x is less than or equal to 0. Because it can be 0 or it can be less than 0. So 0 or anything less is going to be x. But notice that x has to be greater than -3, but it can never be -3 because we have an open dot. So it can get as close as you can to -3, but never actually touch it. Now, with that being said, we talked about domain, so now we got to do our range. So in range, I'm going to do with my black pen. That's my y values. I notice that my dot, if I go all the way across, it lines up with this point, and the highest it goes is right here. So once again, the highest it goes is 0. So I'm going to write my word in here, range, and those are going to be my y values. So my lowest value is right here. It's going to be -3, and we always put our lowest value first. So I have -3, and it is an open dot, so I'm going to put is less than y, and then I have a closed dot at 0, and so it's going to be y is less than or equal to 0. And so now I've written the domain and the range for this particular function that's been graphed. So let's look at the next one. On this next one, we have closed dots on both sides. There's a closed dot, there's a closed dot. So for my domain, I'm going to be looking from this point, which is 1, all the way to where it ends, which is this point, which is 6. And that's going to be my domain, which is my x values. So I'm going to go and say my lowest number is 1, so I'm going to say 1, and since it's a closed dot, I'm going to say is less than or equal to x, which is less than or equal to our biggest number, which is 6. Then when I go ahead and do our range, my range goes from up here all the way down here, and I'm going to write the word range. That's my y values. So my lowest y value, if you look across, is actually going to be a 2. So I'm going to say 2 is less than or equal to y, which is less than or equal to our biggest number, which will be 6. Okay, so now you know how to create an inequality based off a function that's been graphed. So let's go ahead and look at some discrete data. Notice that this is not linear, right? It doesn't have a line that connects all of it, but you do have points that move up. And I think these are actually easier because all you have to do, especially if it gives you the ordered pair, for your x values, you're just going to give the points the x values for the points. So in other words, all these numbers I underline. So for instance, I'm going to start from lowest and go to greatest. So for domain, I have 1, 2, 3, and 4. Right? 1, 2, 3, 4. And that's it. That's my domain. Notice it's already in my brackets. For my range, I'm going to look at the y values. So we have 75, 150, 225, and 300. So now I'm just going to write those in order from least to greatest. 75, 150, 225, and 300. So that is my range. So this, we simply just use our ordered pairs so that we can write all the elements of the domain and all the elements of the range. And that's all there is to it.